All right, so this is where we will pick up part 2 of chapter 1. So this brings me to psychology. And so you may be wondering, again, why is Dr. Wilson ranting about science for the first 12 minutes of class? It's because psychology is a science. And so I'm going to spend a few minutes here, kind of talking about psychology generally. But then we're going to talk more about the history and maybe some of the misunderstandings have come from. So psychology is a discipline that's concerned with behavior and mental processes. Okay, so that's super vague. You might be thinking, cool, but I don't know what that means. So we're going to get more specific. Okay, but we also care about how the individual is going to be impacted by their physical state, their mental state, and their external environment. So I think one of the first misunderstandings people have about the field of psychology is they have a really narrow understanding or narrow appreciation for what the field studies. So every time I am on a plane, I don't know why, but people want to, have conversations, and I just want to, listen to music or watch TV, but they always want to chat. And so one of the questions they always ask is, what do you do? And I have to say, I'm a psychologist, and then I regret saying that for the rest of the flight. Because they instantly think that you are Sigmund Freud, right? They think you are a therapist, that you see patients all day, and then they want to tell you their life story. In actuality, psychology is such a diverse field. There's so much variety in what we do and what we study. So let's take the question, what are the effects of combat on soldiers? And so this is a question that, is particularly interesting to me because trauma psychology is my main area of expertise. And I've worked in the VA. And so I've seen, veterans that have served 1, 2, 3, upwards of 5 or 6 tours in a combat zone. And so trying to help these individuals deal and cope with the effects of combat can be rather challenging because in actuality, a lot of things come together to impact that person. So you want to get an understanding of physiologically, how are they functioning? What's their physical state? Because, what I saw with a lot of my soldiers is that they felt very kind of unsettled. They felt like their heart was racing, or they felt like they were kind of just, bouncing around. They can't sit still. They're very fidgety. Or if they hear a loud noise, they jump. So the physical state matters. We have to think about the mental state or their thoughts. A lot of people that have been in combat that maybe, lost fellow soldiers have some self-blame. They think that they could have done something different or something more. Maybe they have the thought that they're changed by combat and their family will never understand that or be able to relate to them anymore. But we also have to think about, social support, their external environment. We see that a lot of soldiers kind of isolate themselves, because they think people can't relate to them. And so by isolating, they're losing a major source of coping. So this is just one example, what are the effects of combat on soldiers? But this is just to kind of highlight that when we're talking about psychology, there's so many moving pieces and so many factors at play, this can be a really complicated science. So this brings me to another really important point. If you're sitting there thinking, I just want to know how to do well in this class, this slide is for you, okay? Psychology is not common sense. This is the number one mistake that I see students make. When students don't do well on exam 1 and they come to my office hours and we have a little conversation about what happened, the number one thing they say is, I thought I knew it because it just seemed like common sense. So the reason it seems like common sense is everything we're going to talk about in this class relates to you in your everyday life, right? Your feelings, your thoughts, your relationships, how you sleep, how you think, how you feel, all that stuff, right? Your everyday experience, that's what we're studying in this class. So that's the kind of the misleading part, is that it's going to, the material will feel very approachable. But the problem is that it's not just based on opinions. Your experience might be different from someone else's experience. And so we can't assume that our lived experience represents the science. Okay. And in actuality, people just believe a lot of myths related to the field of psychology. A lot of myths. So in general, psychology is very complex, continually advancing. And so to do well in this class, I highly recommend you approach each chapter from the perspective of, okay, this might be something I feel like I kind of know something about because it sounds familiar, or it's just talking about everyday experiences, but let's just see what the science says. So kind of put a hold on your own experiences and assumptions. So the reason that pseudoscience is so problematic is that it often looks like true science, right? And so we see a lot of examples of this right now with the global pandemic. The last 2 weeks or so, there have been some YouTube videos circulating by doctors and scientists, and they're wearing their fancy white lab coats, and they're talking about some of these kind of off the beaten path assumptions. And so it looks like science because these are doctors, these are scientists. They look, legit. They've got doctor before their name. So pseudoscience is problematic because it looks like true science, but it's not actually based on science. In actuality, it's typically going to be based on anecdotal evidence, like stories or just one or two examples. The other kind of red flag that I'm going to be looking for is that it's going to kind of sidestep disproof. When someone throws out something that sounds to maybe discredit it or question it, the way that they handle that is they simply say, oh, well, I can explain that, and then they try to reason their way out of it. Another thing is that it is going to take something super complex and tries to say it really simplistically. In actuality, the complex answer is probably the more legit answer. So pseudoscience is so dangerous because it looks and feels like science. But when you kind of pull away the layers, you're going to see it's mostly based on kind of anecdotal experience based evidence, and that it's, again, kind of it's going to sidestep any attempts to discredit it. So here's a good example. This was kind of big when I was in college, was this Mozart effect. And so the logic was that if you played this tape of classical music for your baby, either when they were in the womb, if you just kind of played it, or, once the infant was born, just kind of played it in the room, that it would actually improve the cognitive functioning of babies. And so mothers were buying this CD. They couldn't keep it in stock. It was flying off the shelves, and people really bought into this because, again, it kind of felt and looked like science. They threw up some graphs that showed that cognitive functioning improved, and in actuality, this wasn't science-based. It was just pseudoscience. But what's kind of interesting is then other people started to kind of apply this to themselves. We noticed that college kids started to study with classical music on. And actually, maybe you're one of those people. Maybe, you think that classical music improves your ability to focus and study. And so maybe you play it in the background. And so this is just an example of a pseudoscience, assumption that kind of got some traction, and people thought it was based on science. So I kind of want to pause for a minute and just say, pseudoscience isn't always dangerous. So if you play classical music when you study, as long as it doesn't distract from your ability to study, if it doesn't, lead to negative consequences, there's no harm in thinking that. There's no harm in playing music. But when it's something that impacts your functioning, or something that maybe then impacts how you treat other people or the advice you give to other people, that's when it's problematic, right? So if I believed the Mozart effect and then required that all of you study with classical music on in the background, that's problematic, because then I'm making far-reaching decisions based on my belief. So again, just want to kind of pause and say, just because I call out an example that maybe applies to you doesn't necessarily mean that it's a wrong belief. Let's just think about some of the consequences to the way that we arrive at conclusions. So this starts to introduce the question of, well, okay, we have pseudoscience. So how can we think more critically? So here are just kind of a few examples of questions to think about. How do we know the things we know? So how do you know that George Washington was the first president of the United States? Other than watching Hamilton on Disney, how did you learn that? How do we know that? How do you know that you have a stomach? Have you seen it? Have you held it? How do you know what color the shirt is that you're wearing? So again, kind of silly questions to think about, but really kind of ponder and pause for a minute and think about, where do we get our information? So I know Washington was the first president because an authority figure told me that, right? I think it was like my second grade teacher. That was a thing I was told by an authority figure. The way I figure out that I have a stomach is that I have an understanding that all humans have stomachs. I am human, therefore I have a stomach, I think, right? So that's using reasoning. I know the color of my shirt, which is red, because I can observe it. I can look at it. Okay. So there's lots of ways that we can get information. Some of these are more problematic than others, right? What if my second grade teacher had been wrong, right? Authority figures are only good as sources of information if they know what they're talking about. So science is going to put a greater emphasis on higher quality evidence, and the main one being observation, right? Because reasoning and authority can have some problems to them. So to kind of think about this in a different way, science relies on empirical evidence, and one of the ways we can get empirical evidence is through observation. And so empirical evidence can come from several different sources. Again, one of them I just said is observation. But it isn't just watching. Okay, observation is systematically collecting information. And the key word there is systematically, not kind of haphazardly or lazily collecting information. There's going to be a system to the way you collect it. Experimentation, which is systematically testing. So arriving at an assumption and then putting that assumption to the test. And then measurement, again, the key word here being systematically measuring things. So again, I hope you're seeing that the key word across all of these ways that we can get empirical evidence is the word systematic. So what is critical thinking? So critical thinking takes our understanding of information beyond just kind of opinions or just kind of, again, lazy observation. It's the ability and willingness to assess claims and then make objective judgments based on the observable data or the information that we've systematically measured. So critical thinking is the fundamental building block to any science, okay, chemistry, biology, psychology. And so critical thinking is the main thing that's going to help us distinguish scientific psychology from pseudoscience. And so to kind of break this down into steps or kind of a process, I have five different steps identified here. So the first thing for critical thinking is you have to ask a question. Okay? So let's just take, again, one of those kind of everyday examples that maybe you've had before. And so my question is, does exercising make me happier? Okay, so the next step is going to be define your terms. Okay, so this is where we take kind of a vague question and make it more concrete. This is the first step to taking it from just kind of a lazy, kind of everyday, random question and make it science. So you have to define your terms. So when I say exercise, I mean 30 minutes of running. And by happier, I mean having a positive mood more than 75% of the day. Okay, so I've taken this kind of vague question and made it more definitive or concrete. So the next step, and this is another kind of key point of taking it further away from pseudoscience, is that we have to figure out what are the assumptions and the biases that are going to get in my way here. So for me, it would be that I've always kind of assumed that exercise will improve my mood because then it validates the effort I put in. I don't know about you, but going to the gym, getting on a treadmill and running, that takes a lot out of me, right? There has to be a lot of motivation. There's a lot of effort. And so I've kind of always thought, well, of course, exercise will improve my mood just as a way to kind of validate what I put into it. So then I'm going to examine my evidence. So for this, maybe I would look at large-scale, high-quality studies that have been done, because I know that they're out there, right? There's dozens and dozens of studies that have questioned this, probably with thousands of participants. And I look and I see, oh, yep, most of these studies show that, yeah, exercise is going to, that's a typo. This should say has shown that exercise, not research, does boost mood. And so that's what the science says. That's what the empirical evidence is pointing to. And so by weighing all the things that I know, I might arrive at the conclusion that, well, my temporary understanding is that, yeah, exercise is going to boost my mood. Okay.